Okay, let's unpack this. Imagine you're standing at the edge of a mangrove swamp. The air is thick and humid, and then you see it, a flash of color so intense, it almost seems unreal.
Like a brushstroke of pure scarlet against the green and brown.
Exactly. And you realize its most shocking, vibrant characteristic isn't coded deep in its DNA for, camouflage or some kind of threat display. It's basically a receipt for lunch.
It really is. And that's what we're talking about today.
We are diving deep into the world of the Scarlet Ibis, a creature so vividly, intensely red that it forces us to reconsider one of the most fundamental rules of biology. You are what you eat.
It's a fascinating deep dive because our mission today is to look at how one single element, its diet, can so fundamentally shape an animal's entire identity.
And the implications of that are huge.
Well, absolutely. The scientific implications for how we even classify a species. Intense scarlet color. Well, it's the key to everything. It's the aha moment we're going to keep coming back to.
When you look at one, it's not just red, it's overwhelming. The plumage is described as everything from flamingo pink to deep magenta, even a fiery orange. But Scarlet Ibis, that name really sticks.
It does. And for all that visual drama, they are surprisingly petite.
Yeah, I was shocked to learn that. They're only about 60 centimeters tall.
Just over 2 feet, yeah. And they weigh just a little over a kilogram. So they're compact, but incredibly visible.
And they have those long salmon pink legs and that very distinctive, thin, curved bill. It looks perfectly designed for
probing, for foraging, exactly. That bill is their primary tool.
So where do they fit in the grand scheme of things, classification-wise?
Well, the Scarlet Ibis is one of 2 living species in its genus, Eudosmus. It's part of the wading bird family, which includes other pretty striking birds like the roseate spoonbill.
Okay. But the really interesting comparison is with its closest relative, isn't it?
That's the one. Its northern counterpart, the American white ibis.
Which is, well, it's white. Pretty drab in comparison.
Completely. Mostly white with black wingtips. You couldn't design 2 birds that look more different, but are genetically almost neighbors.
And what about their feet? I found this interesting. They're waders, but they don't have super webbed feet.
Right, and that's a brilliant adaptation. It lets them move through that soft, gooey mud without getting stuck, but it also gives them the dexterity to perch high up in trees. A really neat trick.
A great survival trait. Okay, but let's get to the main event. Here's where it gets really interesting. Why are they so incredibly pink?
Right.
We know it's diet-driven, like a flamingo, but is the color actually required? I mean, why do they need to look this way?
That is a fantastic question because it gets at the whole cost-benefit of being a giant red beacon for predators. And the answer is, it's not required for survival in the sense that they'll die if they're pale, but it is absolutely 100% required for reproductive success.
So it's a signal.
It's the ultimate signal. The intensity of that scarlet color shows potential mates just how healthy and successful you are. A brighter bird is a better forager. Simple as that.
That puts a whole new layer of pressure on finding a good meal. And what exactly is on the menu that causes such a dramatic transformation?
They're connoisseurs of crustaceans, basically.
So shrimp, crabs, that sort of thing.
Shrimp, crabs, mollusks, insects, yeah. Anything they can root out of the mud with that bill. And the secret is in those red shellfish.
The secret weapon.
The secret weapon is a type of pigment, a carotenoid called astaxanthin.
The same stuff that makes salmon pink.
The very same. Astaxanthin is responsible for so many of the reds and oranges you see in nature.
So, okay, the ibis eats the shrimp has the astaxanthin. But why does it go straight into the feathers? Don't most animals just, break down their food?
They do. And this is the crucial step. The Scarlet Ibis, like some other birds, actually lacks the specific enzymes to fully break down these carotenoids.
So it can't digest it properly?
It can't get rid of it. The astaxanthin has nowhere to go. So the bird's metabolism just deposits it. It deposits the pigment into the keratin of their growing feathers, their skin.
So it's literally painting itself from the inside out.
Precisely. It's not just a splash of color on the surface. It's structural. It's part of the feather itself.
Which explains why they don't hatch scarlet.
Exactly. The juveniles start out a sort of dusty brown and white. They have to spend their entire adolescence just eating. They have to eat up to get that bright, vibrant adult color, proving their fitness to the world.
It's a living, breathing certificate of health. That's incredible. So shifting gears a bit, where do these flamboyant birds actually live?
You'll find them in the tropical, wet, marshy habitats of South America and the Caribbean. especially along coastlines, river deltas.
Hmm.
Places like Venezuela and Trinidad are famous for them.
And even though they're waders, they're also
They're amazing flyers, right?
powerful flyers. They migrate long distances, often in that classic V formation you associate with geese. Very efficient. But it's the short distance flights that are really the spectacle.
Oh, yeah. The sheer numbers are just astonishing. They're super social birds, and they fly in these incredibly large, dense flocks. It's like a cloud of red moving across the sky.
So what's the thinking behind that? Is it just that they like company?
It's pure survival math. Ornithologists call them super social serial monogamists, and that social structure is all about safety in numbers.
The dilution effect.
The dilution effect, exactly. If you're in a flock of 30 or more birds and a predator attacks, the chance of it being you specifically goes way, way down.
Living shield made of your friends.
Basically, yeah. And they even extend the invitation to other species. You'll often see them hanging out with spoonbills, herons, ducks.
More eyes in the sky.
More eyes, better security. It's a bustling, very cooperative wetland community.
So speaking of community, let's talk about family life, courtship, nesting. What's their approach?
Well, they're communal nesters. They build their nests very close to other pairs, often clustering dozens of them in the same mangrove tree.
And the nests themselves are, let's call them minimalists.
Minimalist is a kind way of putting it. Artless is another word I've seen.
Yeah.
Just loose formations of sticks. They definitely put all their aesthetic effort into their plumage, not their architecture.
So when breeding season comes around, the male has to put on a show.
A big show. It's this whole ritualized display of preening, shaking, head rubbing, and these dramatic flights to show off how high he can go and, of course, how brilliantly red he is.
Yeah, scarlet plumage is his entire resume.
It's his entire dating profile, yeah. Once that works, they mate, the romantic cloacal kiss, as it's sometimes called, and then the female lays 3 to 5 eggs a few days later.
And then the whole cycle starts over.
It brings us right back. The moment those chicks hatch, the clock starts ticking for them to get enough of that pigment-rich diet.
Yep.
Their whole transformation is built on a continuous supply of astaxanthin.
It's just such a powerful reminder that their identity isn't just influenced by their food, it's literally constructed by it.
Right.
So what does this all mean for science? Because if the color is purely from what they eat, that must throw a huge wrench into how we classify these things.
This is where we get to the really deep part of the dive. You have two birds that look completely different. The red scarlet ibis and the white American white ibis.
Eudocimus ruber and Eudocimus aldus.
Correct. But underneath the feathers, genetically, they are almost identical, which has led some researchers to argue they shouldn't be two separate species at all.
I can absolutely see why. If the only real difference is environmental, a coat of paint, then why are they classified separately? Maybe you can break down that idea of genotype versus phenotype for us.
Of course. The genotype is the underlying genetic code, the DNA blueprint. And for these two ibises, their genotypes are remarkably similar.
Okay.
The phenotype, though, is the physical thing you can see, the observable characteristic. And their phenotypes are, well, they're night and day, red and white.
And the controversy is that we traditionally classify based on what we can see, the phenotype.
Exactly. If you just looked at the DNA, you'd say one species. If you just look at the birds, you say obviously two different species. It really challenges the whole system.
So science is debating whether a temporary food-based color change is enough to grant you your own species status.
It is. It forces us to ask how we define those boundaries in nature. The color is plastic, it's changeable. If you took a population of white ibises and moved them to the coast of Venezuela,
they'd eventually turn red.
They'd turn red. And if you took the scarlet ibis away from its crustacean buffet, future generations would grow in much paler, whiter.
And I read that in places where their ranges overlap, you actually find pink hybrid birds.
You do, which is powerful evidence. It shows they're interbreeding, that they're probably just geographical variants of the same core animal. The whole story just reveals the incredible power of environment over appearance.
So the ultimate takeaway is, this is a small social bird whose entire identity, the very thing that gives it its name, comes from a single chemical in its food. And that fact might just rewrite its spot in the biology textbooks.
Right. It forces us to look past the superficial differences. Sometimes the most dramatic distinctions in nature aren't coded in the genes. They're just painted by lunch.
It certainly seems that way. And that brings us to the final thought we want to leave you with. Building on that dependency, given the growing impact of climate change, of habitat degradation on these coastal wetlands, What happens if the crustacean populations that feed the scarlet ibis begin to collapse? Is it possible for an entire species to lose its color, to revert to that paler white ibis phenotype, effectively becoming a different bird overnight just because of environmental stress?
It's a sobering thought. It suggests that a species' identity might be far more fragile and fluid than we ever assume. A truly vibrant distinction, just one meal away from fading entirely.